And the logic clock monitoring unit, where whether you have a fault on your if your microcontroller is not starting, that would require a hardware implementation where you can see if you have a fault because you have a issue with the logic block. So you also require over voltage and under voltage. Now you can obviously monitor these with respect to firmware, but you can also have hardware implementation of these faults in case customer needs it. Some customers prefer to have some faults not be controlled by firmware. So you can have a choice as to give your customers a few options in terms of being able to shut down the inverter with hardware or with firmware. Here you're disabling your bridge through hardware when you detect these faults. So looking at the Hall code errors, let's say you have 3 Hall sensors and you have this north-south pattern. Your Hall sensors are within one quadrant here. So you can look at a gray coding where you can essentially make your Hall codes into a gray code, and thereafter you can look at the sequences and you can look at whether you are getting invalid sequences. So this is one hardware implementation of it, where you can implement with the combination of AND, NAND, and OR gates in a latch. You have a fault which can be used to disable your inverter. And here is another hardware implementation where you and I have a transition detection, 3 AND gates, OR gate, and latch to figure out fault action mechanism. And this is an example. For example, this is your Hall sensor H1, Hall sensor H2, and then every transition you have this transition pulse. And then you have a transition pulse for H2 here. And then when you have an issue with your Hall sensor here, you're going to automatically delay the fault. And the fault will remain on for some time. Okay? And then you can clear the error, and then it can clear it. So that's one way to implement hardware side of things in terms of detecting all sensor faults. So this is your another way to figure out your logic main block issue. Then you can have an optional PLL here, pulse counter, and then you have a digital comparator here and digital comparator here, and then a gate here to get you clock fail signal. So that's one way to do the hardware implementation of keeping an eye on your clock. Okay, so over temperature sensing is essentially you need the over temperature sensing for power inverter block as well as for the controllers as well as the PCBs, and that can be directly routed to analog to digital converters with simple ICs. So that was a quick overview of our faults. Any questions before we go to the next section? All right, so back into